Welcome everybody. I'm Mark Fox, CEO of NetEvents, and delighted you can join us for this session today on AI with everything, the future of artificial intelligence in networking. Chairing the session today, we're delighted to have our partners from IDC, Mark Leary, who's the Research Director for Network and Analytics and Automation, and joining Mark are IBM, NVIDIA, and VMware. So three of the big guns in this space. Mark, thanks very much again for chairing this session. Over to you to introduce everybody.
Alrighty, great. Thanks very much, Mark. Welcome today to the audience. And I wanted to introduce my speakers very quickly now. We'll get more details from them when we open up the panel later on in this session. But first, joining me is Andrew Cower, the GM of Software Defined Networking at IBM, Kevin Deierling, Senior Vice President with NVIDIA, and Gaurav Rastogi, Senior Director, Research and Development for VMware. And again, I'll let them provide more details on their backgrounds and what they work on these days later on as we open up the panel. I wanted to open up with the first of just a few slides on AI that really will set the stage. No pontificating from the analyst today. You're probably all breathing a sigh of relief. You sit on a lot of those, I'm sure. But I wanted to really set the stage in terms of why networking, why AI. It's funny, I was looking at the intro and saw auto AI as identified as capturing the transcript, and it was taking me back to my early days in college doing artificial intelligence work, and this goes back many decades ago, and we were doing some very, very crude conversational interactions that, oh boy, if you use more than 5 or 6 words, good luck to you in getting anything accomplished. So really how far we've come, it's amazing. But we'll talk about AI, particularly in networking. And in our conversations with Kevin and Andrew and Gaurav earlier, it certainly becomes apparent that AI in networking, should be pervasive in networking. It's not just in one area. My focus at IDC is network analytics and automation. So there's a lot of AI and ML developments in that space. But I can tell you there's just as much going on within the infrastructure itself and intent-based networking, all the things that we're looking for today in technology from networking. And certainly the Google Cloud outage yesterday, we haven't heard the complete forensics on what it was caused, but it was identified as a networking problem. The Facebook problem a month ago, same thing, another networking problem. And we've seen a wealth of these over the last few years. And this is Facebook, this is Google, this is AWS. These are people that with a lot of sophisticated expertise available to them, a lot of automated systems, and yet they're having problems with the complexity that networks presents to them. And these pressures are building. And, it's funny, I was creating this slide and literally this is a simplified version of the pressures that networking staff faces. Many of you in the audience are looking at these kind of pressures and just saying, how do you do this? I'm reminded of the old FedEx commercial where the person's on the phone. I can do that, I can do that, I can do that. They hang up the phone, they say, how can I do that? And that's the reality for most networking staff these days, is they're faced with a lot of new kinds of responsibilities on the left side of the equation. No longer are they just simply deploying routers and switches and changing configurations and making minor tuning adjustments to the network. They're worried about the digital experience of the user. They're getting more involved in business outcomes and doing more evangelism for the network with lines of business units. What can the network do for digital transformation? Now, these are high-level conversations that the technology-focused networking folks are having difficulty dealing with. And why is that? Well, you look on the right side of the equation in terms of all the technologies that are coming at them. Intent-based networks I mentioned before, SD-WAN, 5G, all of the options that are presented to them to, quote, make their network better. And how do you define better? Well, you can see by the list, it's not about making the network simpler, unfortunately. For that, we really have to turn to smarter systems that are driven by AI and machine learning, systems that do a lot themselves and take care of themselves and bring that kind of dynamics that we want out of our network infrastructure and avoid problems like have been created, we've seen in the last month, in the network as people change maybe one configuration parameter or they ran some sort of automation script. And obviously, the governance is just as important as the development relative to these automation scripts. So making sure those things are valid when they're running. So a lot of complexity. Da Vinci said it best: simplicity is the ultimate sophistication. When our networks get to the point where they're as simple to operate as, say, our computing infrastructures that we've seen, the dramatic simplification associated with cloud services, again, that's when we're making good progress. And we're letting the networking staff focus more on that left side of the fence to deliver real high value, as opposed to doing deployment and doing operations and spending way too much time resolving problems, even identifying problems and chasing down threats. So all of those things, we're trying to relieve pressure on the staff there. And I do think it's interesting, what's a slide deck from IDC, International Data Corporation, without a data slide? And I find this a fascinating view. It's funny, we saw Auto AI and doing our transcript for us here. Certainly with computer vision and things, we see a lot of dramatics, robotics on the manufacturing floor, all the kinds of automation we're seeing in healthcare and retail and such. Those draw a lot of the AI attention from the press, from people that are writing articles and the news, and you see what's going on. So again, robots, vision, cars, smart speakers in your house. Again, the AI capabilities there draw the attention. But if you look at IT execs and where their priorities are relative to using AI, they're much more focused on doing better with what they have. IT automation is always a top concern for IT execs. A lot of projects going on there, a lot of disjointed projects at times, a real big lack of governance, as I mentioned before. But IT automation, a tremendous area for AI, bringing its smarts to not only development and governance, but also the triggering of automated events and directing automation activities and such. Number 3, smart networking. However you call it, SDN, intent-based networking, smart networking. There's a lot of terms that point towards a more dynamic network infrastructure, one that's easier to manage, that's more secure, and that is better at adapting to requirements as they develop, whether they develop a minute from now or whether they're developing with some sort of big new digital rollout that's going on with the company. And finally, you see security. So right in the top 5 of AI in terms of IT execs, and this was a very extensive survey worldwide, over 2,000 respondents, the top 3 are focused in on infrastructure. They're not focused in on smart speakers and robots and all of that kind of thing. They're trying to figure out how to get better at delivering an infrastructure that's truly resilient in the digital age. IDC does predictions every year, and this is from our most recent prediction. It's funny, a whole team of folks that are involved with AI and AI-infused infrastructure. We put together 10 predictions for the coming year, and we always go back and forth. It's a very lively discussion about what percentage. I think 60%, I must say. I think this is very low. I think that sets a very low bar for enterprises overall. I think enterprises, whether you're small, medium, or large, AI should be infused within your IT infrastructure somewhere along the way, probably in many points of your infrastructure by 2024. That's 3 years, 2 years away now, just over 2 years away. But again, we'll hear from vendors later on in terms of how they're delivering that. And a lot of times the AI infusion is something that you don't really see, but you realize the benefits from. So I think this percentage is actually a little bit low. Don't tell my IDC colleagues, this is where we ended up with all the arguing was done, but I think that's low. And I think you look at those examples like event correlation, anomaly detection, these are things a lot of systems are giving us today, but we could certainly improve upon. So people are getting, they're wetting their whistle, if you would, on today's functionality relative to identifying threats or looking at behavioral anomalies in the network, figuring out what's going on here. Again, problem resolution times are dropping as a result of these systems. And certainly with AI and ML-driven analysis that goes into, combined with all of the data gathering associated with network analytics these days, and this provides a lot of feed, not only to the operator, but to intelligent analytic systems, triggering automation actions, also within the infrastructure itself, triggering solutions so that they self-adjust and they self-drive. The Tesla of networking, if you would, We're still a long way from that. But again, AI, ML-driven systems certainly get us there and solving some of the complexity challenges, the volume problems we have, and probably going a long way to solving some of the problems like we see with Google Cloud yesterday or Facebook a month ago, where an operator enters in a wrong configuration or a configuration command is entered via an automated script and that hasn't been validated or something all across the network. That's a result of the networks just getting out of control and being too complex to really figure out everything. And you see the interaction amongst all of the network devices, the network services within a network. When one goes bad, the dominoes start to fall. And that's where you get into these serious outages and suddenly losing websites and such. And on the right, you do see some more data. We've been doing this survey every month for the last couple of years where we try to examine the movement of digital barriers. And when someone's building out their digital infrastructure, what are the barriers that are presented? And this is from the last few months. And again, still a lot of trouble with performance and security concerns. Cloud services, although on one side, they've been very helpful on data center build-outs and services and application rollouts. But on the other hand, we are highly reliant on them. And all of a sudden, when things happen like yesterday, we realize how reliant we are on them. That's why people have multi-cloud strategies where they have multiple clouds in their infrastructure and they're leveraging different vendors for those services. That raises the complexity even further. How does this application or this management functionality compare for AWS versus Azure versus Google or something? A lot of complexity there. And complexity always results in higher costs. Higher costs on the part of operator effort, the organization, the subscribers' effort that they have to put in overseeing their services, but also it results in higher costs relative to the services yourself that you're subscribing to and trying to figure out, are you using your service fully effectively? On the left, these are the problems that we face. We talked about complexity, cloud control. Staffing constraints are a particularly vexing problem. We've seen over the last decade or so, the budgets associated with networking staff has almost been halved. So it was somewhere around 14 or 15% 12 years ago. Now it's in the single digits, high single digits, 7, 8, thereabouts. So we're dedicating less money to staff, which means we're hiring more junior level folks, maybe higher end folks. They themselves make decisions as they move up the ladder, as they move from, say, a CCNA certification up to a CCIE certification. They themselves face decisions along the way. Do I want to stay in networking or do I want to venture off and have a double major and develop my security knowledge, my cloud knowledge? Well, if you look at opportunities and premiums paid for certifications and just, again, the salaries associated, security, cloud, application development, these are highly attractive opportunities for people that are starting off in their technology journey, the technology career journey. And so as a result, people who start out in networking, they find that's a good basis for moving into security, moving into cloud networking. And as a result, that really causes a problem in terms of the supply of networking staff, the experts that are available. And oh, by the way, the most experienced, most expert folks, the CCIE is now 27 years old, that certification, the highest level certification in the Cisco training regimen. Those people are reaching retirement age. So over the next 5 to 10 years, we're going to see a significant brain drain from the networking staff. So how do you squelch that? Well, our systems better get a lot smarter and take a lot more responsibilities for themselves versus relying on operators that, quite frankly, there's going to be less and less of them over time. Security is always a major threat. Being smarter about what's flowing across your network. We're just really seeing now the silos breaking down. The number one permanent change we saw for IT operations in the survey result last winter, the number one permanent change coming out of was networking and security staffs working closer together. More teamwork associated with those two particular groups within IT. Suddenly the remote users are spread all over the place, a lot of threats developing, a lot of gaps were created in security vulnerabilities and such. So as a result, smarter and smarter systems are looking for those anomalies looking at certain threat profiles, identifying things earlier. The famous industry stat that says threats exist within networks for 2 to 3 months before they're even discovered. That has to do with systems being smarter about what to look for, what to identify, what to be directed to look for, but also learning as they go. And again, that's where the intelligence comes in for these systems. And network automation we talked about before, where governance, validation, testing, currency, all of those things are very much a needed requirement in network automation. We're seeing people just starting to scratch the surface in terms of developing automation, whether they're using third-party products, whether they're developing their own playbooks or programs and such. The reality is and the focus has been almost entirely on development. Well, what happens when you run that same playbook 6 months from now and you've made changes since? Is it still valid? So again, governance is as important as development with network automation. And with that, that's my real final comment in terms of setting the stage. And I'd like to bring in my panelists now, and we'll go through a series of questions focused in 3 different areas. We'll look at the demand for AI, where customers are, what they're asking for, how these vendors go about delivering AI capabilities, and certainly in between is the development side. We get a lot of hype associated with AI, and sometimes your eyes can just glaze over. You're hearing it from everybody. The whitewash is very, very strong. Believe me, I hear it every day. So getting a view in terms of how these vendors, the kind of effort they put into development, is very key to discerning what's real and maybe what's more marketing from some of the stories that you're hearing. Because believe me, you should be putting pressure on all of your vendors that you're speaking to, but anyone that's related to the network at all. What is their approach to AI? What are they providing? What are their priorities? And we'll get into that with the panelists now. Andrew, if you want to lead us off with a quick intro.
Sure. Good morning. My name is Andrew Coward. I'm the general manager for IBM's new software-defined networking group. This is a new group for IBM. We started back in January, and really recognizing a lot of things that Mark talked about, how this industry is in this huge transition. Whenever you see the word transition, you kind of think opportunity, and that's really what we thought. Before I joined IBM, I ran a company called Lumina Networks, which was in the SDN space. And I've obviously been in networking for a long, long time now. So, when it comes to machine learning and AI, it's actually been 10 years since IBM Watson won Jeopardy, if anybody remembers that. And in those 10 years, you might ask, well, what's IBM being up to with machine learning? It hasn't won another episode of Jeopardy, or kind of like doubled down on that one. And so what we've done really is apply AI into multiple domains across our business, right? So whether it's IBM Watson Health, whether it's security, or whether it's networking. And so from a networking perspective, that's kind of where I focused since we joined, but obviously I'm working off a legacy of at least a decade of how we're applying this technology into this space.
Thanks, Andrew. Kevin Deierling from NVIDIA. I'll let you do your intro.
Super. It's great to be here. I'm Kevin Deierling. I run the networking business at NVIDIA. I joined NVIDIA about 1.5 years ago through an acquisition that was made of Mellanox Technologies, where we do high-speed networking, InfiniBand, and Ethernet. And so essentially, AI is really the focus of NVIDIA and accelerated computing. And the networking is pervasive in everything that we do. And so now we're seeing AI being applied to networking as well. It spans from the core to the edge to data centers, really everywhere. So we have huge data centers with 10,000s or hundreds of thousands of servers. And then we have tens of thousands of data centers in all of these edge environments. And all of those are actually being AI enabled today. So it's a very exciting time to be in AI enabled network.
And the third member of the panel, Gaurav Rastogi from VMware. Gaurav?
Yeah, so I'm Gaurav Rastogi, and I lead the R&D teams in that VMware's software-defined networking business unit, NSX. And I came to VMware through acquisition of RV Networks, where we build the next generation of web application firewall and API security. My team is essentially focused on looking at analytics and AI ML to automate the decisions that most application admins encounter, like complex decisions, and how do we tie it into automation based on that decision. So the goal is really to simplify and secure modern web applications.
Thanks very much. The first question, I'll start with you, Andrew, with the first question, but Kevin and Gaurav, feel free to chime in after Andrew finishes here, is when you are talking to customers, what is the focus of the discussion around AI and networking?
Yeah, well, I think certainly over the last 5-6 years, our customers at IBM have spent a lot of time gathering or pulling in lots and lots of data from all kinds of different systems, whether it's Wi-Fi, whether it's the wide area network, whether it's the cloud, on the premise that they didn't have enough information about what was going on, and they couldn't quickly solve problems that happened because they didn't know why or how or where. And the paradox has been that the more information they've collected, the less clarity they seem to get over exactly what's going on. And so a lot of the discussions are really focused on how do I use AI to kind of separate the noise and focus on what's really the problem. How do I get correlation? If something breaks here, what is affected here? If I see this error here, does it mean anything? What's important about it? And so it's really that kind of output from there. Remember, the output from machine learning is not more data. The output for machine learning often is a program or a rule set or something that can then be applied. And so a lot of the discussions talk about, well, I want more data, I want clarity in data, where actually what the output is a program, something that can be actionable and then used. The ultimate destination in all this is, of course, is kind of the automation, closed loop automation. So machine learning is fixing this dynamically and so on. We'll probably get into the trust part of that conversation as we go through the panel today. But to get to that point, there's a huge amount of things that have to happen around just being able to gather and distill the data that's actually been available today from all across the network, all the tools that are around.
Yeah, I might just add, that Andrew mentioned trust. That's the other area where customers are really, really interested, because what's happening, in addition to that massive amounts of data and being able to operationalize that data by using machine learning to write a program that can then do inferencing to guide your activities, we're also seeing really the atomization of the network. So it's breaking these monolithic applications up where you could protect physical servers into these containerized microservices. And the impact on the networking is massive. Suddenly you've got 1,000 times more east-west traffic inside of the network. And instead of being embedded into a single software program, now you have connections between all these microservices. And in a zero trust environment, none of it can be trusted. So in the old days, you could protect the perimeter of your firewall from the outside world, and you were good. Today, nothing can be trusted. No devices that are being brought into the network and plugged in. In the edge, it's even worse. We don't have the guns and guards and gates that you have in a traditional data center. So the network itself needs to be self-protecting. So the whole notion of cybersecurity is an area where we just see huge interest from customers.
I think kind of linked to that, there's this really interesting problem, if you like, that the changes that are happening in configuration dynamically in something like a Kubernetes cluster are happening faster than humans can understand. I don't mean we don't understand it at all. I mean, it would take you an hour to figure out what a Kubernetes cluster had done in a minute. And so compound that through the course of a day, and it's very, very hard to just keep up with this constant shift of change that's now just kind of built into how we do networking or how we do compute.
Yeah, I'll just dovetail to Andrew's point, right? Like when the pods are deployed and when the applications move or transform, you cannot just look like as a black box, the network. You really have to make that connections real time between application and network. And what Kevin was talking about is a real problem. Like a pod moved from one host to the another host, your policies need to follow the application and follow the behaviors. And when there are attacks, or if you look at the statistics, about 85% of the breaches are like web application are directed toward web applications, and about 50% of them are about stealing credentials, right? So when the attack happens, when the breach happens, it is not a single event. This is a sequence of things that goes on, and network is the place where you are able to really see the baselines and the anomalies disrupt. But it is not a stable or a consistent network. It is changing as the apps come in, as the Kubernetes fires. And so for modern applications, you really have to do it as the logical staging, not just going to look at the packets and try to make sense out of it.
Yeah, those are all good points. You know, the network is a very fluid environment, and certainly the intelligence of the network and AI infusion within the network certainly helps with that fluidity, if you would. Andrew, you were reminding me earlier of the Watson example of winning Jeopardy, and your comment about staffing and operators and being just, you know, they're overwhelmed by the data that they're presented to. Is that, you know, it's funny, you know, and I referenced my early days of artificial intelligence work, you know, decades ago, and it was, you know, it was funny. The judgment was, oh, could you identify whether this is a human or whether this is a computer on the other end of your conversation when your computer, and so the equation of humanity was this big bar. That was the bar for AI. If you could do it, you were smart. If you couldn't do it, you weren't AI yet. And it's funny with, as we've seen with robotics and manufacturing floors, certainly what you just alluded to, Andrew, this ability to process data and really make and actually do better than the operator. And that's some psychological learning on the part of the operators themselves. But, you know, with all the data that's presented, the system's ability to process that data and then make a much more precise decision, or make a more accurate, take a more accurate action, if you would. Lord knows we hear all the time about, oh, the operator entered a misconfiguration command and boom, took down the whole network. And, you know, when it happens in a cloud service, it becomes very visible, but it happens all the time in everybody's network. So from that perspective, doing better than the operator can do, and really allowing the operator to focus in places where they have more of an impact, you know, the digital experience and accelerating digital rollouts, things like that, that again directly relate to what their organization is trying to accomplish.
Right. We find so often a lot of it is around to your point, around the correlation of those facts, right? So one thing happened, a link failed, or the network is down, whatever that means, right? What are the correlation factors that then play into that? And so we spent a lot of time there, and there's a human element to this as well, which I find really interesting, which is the machine says, I have a 80% confidence factor that these 5 things came together to create this event. And you then say, well, that's not possibly right, because I know those 2 things are completely separate. And you push that back into the machine so it learns. So to the trust point earlier, it's that, you know, these things don't just instantly know everything, right? They have to be trained, and they have to build up a base of knowledge, and humans are intrinsically part of that before they can be trusted to go and make the changes that they're suggesting happen.
Yeah, Mark, I think it was great that you invoked the Turing test of being able to tell whether it's a computer that you're talking to or a real person. And AI is really right at the cusp. And today, I think it's very, very hard to tell. And it's interesting because you mentioned natural language processing, and you've got, you know, the avatars and all of those things. It's incredibly dependent on the network, because for someone to engage with an activity, an AI device, and get human response times means that the network and all of the connectivity needs to be operating flawlessly. So doing natural language processing, speech to text, visual analytics, all of those things happening in real time. There's so much data being processed. And again, you also said that really that's where your focus should be. That's where businesses should be focusing, is on that higher level. We need to automate and provide all of the networking capabilities that support that automatically, detect what needs to be super low latency, what can live with a lower quality of service, and make all of that happen. Because if you're down trying to dial those sorts of knobs, there's no chance that you can be using AI in your business. And I think that's a key observation that you made, is really don't focus on the low level. You need to operate at the high level and work with vendors like the IBMs and VMwares and NVIDIAs of the world that can provide this.
Yeah, a quick note on that. Like, you also need to take the AI and kind of attach it to what we call action. Like Andrew also mentioned that, right? Like when the decisions are built on AI, there will be false positives, and there needs to be a way to kind of measure the efficacy of what it is doing and be able to kind of roll back or test the waters. So there's a kind of a traffic engineering slash like a test and move forward approach that has to be built in. And AI, it will never be a black and white in terms of there is 100% accuracy of the decision, right? It will always be that there is a high probability of what this prediction or this decision is, and it can be wrong. And like Andrew said, humans need to come in and help that out. And for AI networking, whatever decisions coming out, they need to be in tune with what a security or network admin intuition is. And that's very important. Like intuition is very, very important in this for trust to grow.
Right, and to that point, we're seeing some of our customers start to look at building digital twins of their infrastructure, partly through their CI/CD process. So, the algorithm says, go do this, and you run it on the digital twin first. If the digital twin survives, then or gets better from what's broken, then that you're probably in a good place to post that to the rest of the network. So there are some interesting ways of understanding the nuance. Well, it's very nuanced, but understanding what happens in that nuanced world when you go push a change.
Mm-hmm.
And it does, by the way, link back to having a really good CI/CD process as part of your network operations.
Kevin, we'll move on to the next question here relative to what you're seeing from customers and demand for AI and networking. What benefits are customers seeking with AI and networking? And I'm always interested in understanding, when you're talking to customers, are they expecting too much too fast, or are they expecting too little? Are they so kind of washed over with all the AI hype? Do they just say, well, I just really need to do this, when you in fact know they need to do many more things? I'm curious about your feelings there.
Yeah, I think they're actually expecting much too little. I think that AI is going to be much bigger than people realize, and that in fact, the AI is the most powerful technology force of our time. And companies that realize that and embrace AI and infuse it into their businesses are going to succeed, and companies that don't are going to fall behind. So that 60% number, I'm with you. I think it's going to be much higher. I think in 5 years or in a decade, every business will be an AI business. And that's simply a statement of, again, the companies that don't embrace AI are going to fall behind their competitors. And they will become smaller and smaller and acquired or go away. And so also I heard Andrew invoke that notion of the digital twin. I don't think people understand how large the virtual world is going to be. It's much, much larger than the real world. And we're building digital twins of really everything. So we just announced a digital twin of Earth, our Earth 2 computer. And again, Andrew nailed it, that people will define and build products in the virtual world. And the key is to fail fast in the virtual world so that you can succeed in the real world. And so I think people are underestimating what AI, how it's going to transform businesses, because things have really reached a critical mass where machine learning and that SecDevOps and the CI/CD are all converging so that we can accelerate software development. We're in a really unique time. I've been in technology my whole career. I think we're in a really unique time that AI is going to transform every business.
Andrew or Gaurav?
Yeah, I would add to from a different perspective, customers are really looking for simplicity and automation. They Andrew also talked about, which is if you're paying attention to link levels, you are not gonna really get to the higher order decisions. So what they are really looking at is the systems themselves take care of many of the small tuning and things like that. And that is not going to be possible without AI. AI is going to be core piece of how to figure out what is your baseline, what are the optimizations in the system, telling customers what they don't know about their network themselves, right? And AI is going to be centerpiece for that in figuring out look, actually you cluster these workloads together, gives you much better optimization than the other, or suddenly there is activity which is security incident. These learning have to be automated. There is no way admins can do it by themselves. So yes, I think customers are asking too little because they are also wary about it. The incidents like yesterday, someone can twist the same incident and say, well, what if the computer made a wrong decision and brought down everything, right? So we still need to cross that hump of trusting these decisions, and nobody is going to do all or nothing. It has to be very well integrated with the SecOps and the CI/CD pipeline, where you roll out a small piece of change, control the impact, and then further keep rolling out the changes and adjust the learning.
Yeah, I think at a high order though, when we talk to our customers around what is it you need to know and what do you need to know first, when an app when an app stops working, the first question is simply, did the computer break or did the network break? And answering that question really, really quickly will set the whole team off in different directions, right? Did it run out of memory? Did it run out of process, or did some kind of connectivity break? And so that very, very basic question can often take half an hour after an incident to start to figure out, or to say, well, I don't think it's the computer, I'm not really sure. So these are, very basic questions, right? But just getting to that understanding quickly is a kind of critical starting point for many of the conversations we have.
Yeah, and it's even more, that's even if the infrastructure folks notice a problem developing, when a lot of problems are kicked off by the user reporting a problem. Hey, I'm having a problem with this application or getting to this, site or something like that. All of a sudden, it's not only the networking folks, it's the security folks, it's the, computing folks, it's the application folks, it's the data, the data management folks. Everyone's going off, like you said, into their different corners, and who's the first to raise their hand? Oh, I'm innocent. The time to innocence phrase has become popular. And I must say, it just, oh boy, does that grate against my thinking about silos being broken down and teamwork and all of that. But yeah, I hear you on that. That's for sure.
Yeah. So one comment. I think it was interesting that both Gaurav and Andrew invoked this notion of automation and also being able to detect things, figure out what's going on, and that time to innocence. I agree. It's kind of not a good thing from a siloed perspective. But the key thing there is that the network needs to make it simple. There's so much complexity in these dynamic environments where containers are being spawned, coming up and disappearing again before you even realized it. So telemetry is becoming vital in the network. And so being able to generate massive amounts of telemetry and then be able to analyze that and figure out proactively what's happening. And your network needs to become self-protecting. It's almost like antibodies in the human being, that you're going to have attacks. That's implied in a zero trust model. There are going to be attacks. There are going to be things that are compromised. And you need to quickly isolate them and not let them take off in an east-west. You need to contain the blast radius. And those are all networking functions. And again, the networking operator, the IT administrator, can't be worried about those things. It needs to happen as part of these platforms that you're using AI to detect anomalous behavior and quarantine things and keep them from spreading east-west throughout the whole data center before it takes it down, and minimize the impact of any breaches that might occur. And so all of that is super important.
I'm reminded of the old adage, packets don't lie. And to Andrew's point earlier, all this telemetry results in an awful lot of data sets, and those data sets can't be processed by human beings. It's just impossible in the time frames that are required and the amount of data that needs to be processed.
A quick note on that, like a lot of times you also run into the problem that these data, they conform each other, but they don't really highlight the root cause. Like application is slow, yes. There is packet drops going on, yes. And RTT is higher, yes. But these, like all these things are kind of confirming each other, not really telling exactly where the problem is. That's where I think AI is going to help significantly to understand that, okay, all this is happening because one link in the upstream router is actually flapping, and that's causing chaos in the ECMP load distribution, right? So this is what I think the next level of intelligence needs to be brought out by AI, and we have been looking at this problem. It's pretty hard, and there's so much more we can do about it.
Yep. Right, and I think that's exactly the correlation point around. We know these 6 things contributed to this event, and it's almost like a Six Sigma approach. It's the 5 whys. So why did this happen? So to your point, a link went down. Okay, why did the link go down? Oh, because the error bit rate was high on this service, and it crossed this threshold. Why did it cross that threshold? Because so you can imagine how you can kind of get to the base problem through the correlation and just the why kind of digging into it, right? Yeah. And that also, by the way, comes to a really important point with these networks, which is the AI has to understand the topology. And the topology has to be imported. It can't, there's only so much it can learn instinctively and guess, right? And so having that kind of human to say, okay, this is what the network is supposed to look like, and then process that to a base set of information. From there, it can then say, I know, I can draw my correlations better if I know how things are physically connected.
Yeah. Let's move on to development and look at, again, people are getting, they're just, blown away by how much people, vendors market AI and talk about AI. Let's dive into a little bit of the development side that, put some meat on the bones, if you would, or what's behind all the hype associated with, and help customers trying to figure out, what's real and what's not real. Kevin, I'll start with you on this one. Your company's priorities with respect to AI and networking.
Yeah, I think the key there is that we're building a foundation that uses AI for accelerated computing for really any application. And so the key thing there is you need a secure framework to build any AI application on top of. And so, for example, with 5G, we see a ton of use cases where people are using AI-enabled 5G for robotics and smart factories, and you need low latency and slicing and all of those things. So we have an aerial platform that does 5G, and then it really supports all of the AI workloads. So whether that's a kiosk in an airport that's using natural language processing and avatars and visual analytics, all of that needs to be secure, operationalized. But really, we work with partners, companies like VMware, IBM, and others, to actually deliver all of those platforms. So we're building the framework. Similarly, with cybersecurity, we have a platform with Morpheus. So if you look at all of the telemetry data today in a zero trust environment, all of those packets are now encrypted. So the traditional model that allowed you to actually do deep packet inspection and look at all those headers to figure out what's going on, often they may not even be available to you because everything's encrypted. So now, instead of looking for specific signatures where you know what you're looking for, instead AI can change that equation. and say, hey, here's normal behavior. This user, this device, this application, here's the way they normally behave. It essentially develops a digital fingerprint for an activity. And then using AI to suddenly say something anomalous has changed. Often that can be something, for example, normally this field is encrypted, and all of a sudden you're accidentally sending your passwords in the clear. We see often that some of the cyber breaches and things like that happen aren't actually even malicious. It's just bad hygiene, bad corporate hygiene, where people inadvertently are running a DevOps environment and they move their dev environment into a production environment and leave their credentials out in the clear. We can detect that quickly with AI without having to have a predefined set of rules. AI can look at what is normal behavior and then detect what is not normal behavior. Computers acting like people, people acting like computers. You can use all sorts of different neural network models. And sometimes there are even natural language processing models that are being applied here. And then, of course, pushing all of this out with the containers and being able to do that. That's really where we're focused, is to move people in a Kubernetes environment to deploy AI on an open platform, and then go off and work with partners like the VMwares and IBMs of the world to develop solutions.
Andrew or Gaurav?
Yeah, I think there's three things for us that are critical in how we're advancing AI. The first is the fidelity of the information that comes out of the network to start with. We recently acquired a company called Turbonomic. Half that company was Sev1. Sev1 have been amazing at just bringing in, correlating without using AI, a lot of information from everywhere across the network, whether it was logs, whether it was packet traces, whether it's SNMP, and just putting that into a kind of service assurance model. So that's been a critical element. The second piece is making sure we're reaching all the way into the cloud, to the points we've been alluding to actually through this, which is our customers have moved to the cloud. They haven't just moved to one cloud or two clouds, it's 3 clouds and 4 clouds. And so nobody seems to be saying 3 clouds is enough, I'm going to stop there. They just keep going, right? So the network intelligence has to reach into all of those parts. And then the third thing linked to all of these, once you've got all that, the use cases we apply to AI, getting to the point where we're trusted to automatically make the correction and insert ourselves, so we do get to closed loop automation, right? And that level of trust, as I said earlier, has to be earned, and it has to be proven step by step. In fact, one of the things that slowed us down somewhat is that we have to show proof of work. And as you may know, with AI, depending on the algorithms you use, that can be actually quite hard. Right? You know something's right, it tells you it's wrong, but it can't tell you why it knows that. And so being able to show proof of work is actually really important. And so with that, get to closed loop automation, and these problems start to get, not all of them, but a subset of them start to get fixed, because you've seen this thing 4 times before and you knew what you did and you knew why it happened, and now you're executing that same thing again.
And Gaurav?
Yeah, so we can see 3 major trends right now, and that is kind of driving our priorities. So like I said before, web application attacks are on the rise. Like most of the breaches, when you see 50% of them are on web applications. The attack vectors, if you see, are like 60-70% are on the credentials, and about 20-30% are on the misconfiguration. So these are really our key focus, which is driving our priorities on the AI side, to really build out solutions which will protect the web applications, protect the network in figuring out if there is malware installed, or what kind of, like Kevin was talking about, fingerprint, the interactions within the data center, figure that out. And lastly, when we are looking at VMware, like if we are having a technology in pretty much so many different stack of data center, right? Like all the way from application, networking, infrastructure. So one of the things that we are doing is really prioritizing exchange of this data between them. So there's no point in trying to reanalyze data which has already been analyzed in one product. So focusing on APIs to exchange the data, and essentially building solutions which could provide an overarching view of what is going on across your clouds, across your data centers. And then when you need to go deeper into an application or on a network, like a transport zone level, you can do that. So there's a lot of prioritization of making these systems work with each other, and that's how we are leading, prepping up for deeper AI than what we already do today.
Yeah, Gaurav, I'll stick with you on this question here and looking kind of the next stage. And I think it is interesting how all of you seem to agree that the customers expect too little from AI. And I think the other interesting comment, Andrew made it earlier, and you also, Kevin and Gaurav, you also emphasized it, is that customers are looking to accomplish something. But they don't think in terms of specifying. It's not like the old days of networking where I need a switch with this many ports and I need to have this many 100 gig and so forth. It's very kind of cut and dry, and the customer knew what they wanted. Talk about the development process of AI and networking within your group, within your company, in trying to make sure you're zeroed in on meeting those customer requirements, even though oftentimes they go either unsaid or they don't even ask the question because they're expecting so little or something like that. And I'll start with you, Gaurav.
Yeah, so maybe I'll get into the next level. Typically, what we see AI, there are two classes of AI problems. One, real-time AI, and one where you have a lot of data and you are kind of mining, like typical. That's what mostly you come to hear about, the kind of AI where you have petabytes of data, terabytes of data, and you're analyzing it, figuring out what are the correlations, what are the anomalies, what are the clusters, what are the neural nets in it, right? So the two classes we approach differently. And with both of these two, we typically focus on, okay, what exactly was a problem, or what is it an expert admin needs to know and take action on. And then we look at it as, how can I make that into a software, and the core of it is AI. So an example of like looking at a lot of data is like a bot detection, right? Like whether it's a human or computer. Believe me, Mark, we are still stuck on that problem statement. So knowing whether it is a bot and what kind of bot is very intrinsic to what are the next set of decisions that happen, like whether you learn from this transaction, whether you rate limit on this transaction, whether you learn what this transaction is doing to figure out an attack pattern. All these things happen once you focus on this thing. So in this case, you really need to start from, how do you get the data? You need to build a full data pipeline, figure out good data from bad data, clean it up. That's a whole set of activity by itself, right? Like you may do a test environment and that may not give you the real life situation. You need honeypots. You need to kind of correlate information from different sources. And one of the things we are seeing is that kind of analysis has to be done in the cloud. It is quite resource intensive. You need to have now from an end customer perspective, they don't care about that. Like it's your responsibility to do resources. But from an internal perspective, we need to be aware of, how do we manage this lake of data? How do we essentially optimize around it and clean it up? Once the data engineering is done, then you start getting into how many different models which will apply to this particular problem. And that's an art, right? We don't even get to create new models right now. There's just, for every type of problem, you can find a new model. And then you have to test those things out. And finally, where we focus a lot is dovetail the action. On the real time, it looks a little bit different. It's like applications change, network change. So how do you know what is considered a good parameter for an application, or a new application pops in? How do you learn the baseline for that application? So in the real time side of it, the questions we emphasize a lot more is, how do you know there's enough data seen how do you modulate the resources in the real-time environment, and then again focus on attaching it to the next action. What is the next call to action given the decision? So that's mostly our development process. We what I sometimes call, it should be not AI, but AI squared. It's like action integrated AI. And I'm a big believer of that, because what we found was we started with like typical load balancer with 10 metrics, and everyone was pretty happy with that. But then we said, okay, we're going to give a lot of data, and we went to like 1,000 metrics, and most customers said, I don't want that. Like they are too much information is not good for customers to trust the decision. So you really have to focus on that simplicity, Mark, you talked about, and Andrew, you were also mentioning. And so this is these are the two segments that we basically divide the projects, take the requirement, and examples are bot detection and like positive security model in web applications and API security.
Yeah, thanks, Gaurav. Kevin or Andrew, you add to that?
Yeah, I think the real key is not to ask everybody to reinvent the way they do everything. So, people today are using virtual machines, and they have a virtualized environment. So you need to be able to deliver AI for enterprises that are running VMs. Similarly, companies that are moving towards Kubernetes. And, we're working closely with VMware to make sure that we've integrated all of our AI workloads, all those skills for all the different applications into things like Tanzu. And to be able to do that, also we're working with IBM and Red Hat to be able to do that in their environment. So I think the real key is to being able to embrace AI and all the networkings and solving the ingest problem that Gaurav was talking about very, very efficiently, but without requiring people to just completely reinvent the way they're doing things. So it's a way to bring AI into existing frameworks rather than asking for a forklift upgrade of all of your infrastructure.
To go back to the original question about, we take our customers through 3 steps, right? The first step is that we get baseline for the network. And obviously the more time that elapses, the more information you get, the more normalized you understand what a Monday looks like, or what a January looks like, or what the second week in the month looks like. From that, we start to detect the anomalies, and we come out with rule sets to go fix them. So step 2 is detect the anomalies, come out with a set of fixes, agree what those fixes are, and apply them. Step 3 is you trust that point. So when that thing happens again, you go through that fix and you push that out to the network in an automated fashion. And obviously step 2 and 3 iterate round and round in circles once you've got those, and over time you detect more anomalies, less things become uncommon, and more humans actually involved later, because obviously if you detected 80% of things that regularly happen, the 20% that are different, you want humans to start looking at. So that's kind of how we iterate to get AI really infused and embedded into our customers.
Thanks, Andrew. Looking at delivery, and again, quick answers to this, but I'll start with you, Gaurav. And how is networking? This is getting okay. You've developed the solution, but as you said, there's a lot going on after the scene, behind the scenes, and after installation, there's a lot of learning going on. Talk quickly about how that's changing the support service model for folks like yourselves, and in delivering AI solutions and changing customer expectations in terms of the kind of support that's provided, an AI infused solution versus one that, again, on day one, you install it, you configure it, off it goes. AI is something, AI infused systems obviously learn. They are doing something different on day 60 as they are doing on day 0. So I'm curious in terms of how it's changing the support model. And again, just real quick so we can get to our last question in a few minutes.
Yeah, so quickly, like AI is getting infused in a big way in this, right? Like, so one very obvious thing is every time a service request happens, it actually goes through an AI to really look at, has this been seen before? What was the remedy? What was the root cause? And what are the workarounds, right? So the support team instantly moves every service request through the AI. Now, once the AI solution itself has been deployed, one of the big issues for our support is also, they also don't know exactly what is, they are not data scientists a lot of times. So they don't know exactly what it should be doing and what it is doing, right? So internal training is very intrinsic to getting them on board to understand and troubleshoot AI solutions and be able to, like what we have been talking about, digital twins, right? Like be able to replicate some of these things very quickly. Lastly, I would say that from a customer standpoint, we always need to provide enough intuition along the way as the decisions are being made, and in sometimes even we write verbal templates to say scale out happened because of this, right? Even though the decision was made purely on a mathematical numbers.
Yeah. Kevin, Andrew?
Yeah, I'll just add, all of those things are absolutely right. I think the other key thing is the complexity that's involved, what's actually happening is such that you really can't detect it manually. You can't go look at log files or anything else. So I think all the telemetry and the visualization and the root cause analysis for any anomalies or any performance that you might see, that's critical. So there's all these decisions being made. Now I need to be able to visualize what's actually happening and make it simple to consume. And so all of the ML ops and all of these activities are augmented by visualization and really making sure that we can deploy and monitor continuously and provide really good things for what just happened.
I'll let you move on, Mark.
Oh, sure. Yeah. Andrew, you're on. I'll have you be the lead for this one. But, keys to success in some of our earlier discussions and talking in preparing for this, you talked about, things the customer needs to be in sync with you on in terms of making sure they're getting the most data out of AI. What are the keys to success for those customers that are laying the groundwork to get the most out, especially given that they're expecting so little, oftentimes.
So yeah, I mean, we have to have something to work with, right? So the first question is, well, what data do you have today? Where is it coming from? Do you have the fidelity of that data from all the different sources that are needed? Sometimes, if you think about running a global telecom network, then there's external sources of information that can become important, like weather, right? So they become an input into the information that you're collecting, right? And so to the earlier point, understanding language and being able to use that and import that as a data point becomes interesting. So that fidelity of the source of information is the critical piece. Then the other part before you get to AI is, what are you going to do? How do you even act on a change that you need to make in the network? Do you have the right provisioning tools to go push that change? Or is somebody going to have to manually type stuff into 1,000 cell sites or 100 computers to go affect that, right? There's no way, right? So it's that classic thing. You can't get there from here, right? You kind of have to have these systems in place to make sure you can actually act on the information, get the information and act on it. So once you've got that baseline, then you can start applying AI, knowing that both you've got enough data to process and the ability to go execute on that, without spending hours and hours doing it.
Gaurav, you had mentioned in our earlier discussions too about when it comes time to activate and operate an AI-infused infrastructure. You talk about expectations on the customer's part. You had mentioned the keyword of trust, trusting the system, trusting to be able to let the system take control and provide for the inputs that you can get out of the system. And, talk about your perspective there and what's expectations of the customer when it's time to activate and operate.
Yeah, so very importantly, as AI is not like you turn a feature and it starts working, right? There is a learning phase that goes on with it, right? And invariably, there will be false positive. You can only minimize it, but you can never eliminate it completely because assumptions change, apps change, network changes. So they need to really be cognizant about that. When the false positives happen, how to react to it, how to think about automated actions around it. And when they launch AI solution, it cannot be like a blue-green, and they really need to think about how they roll it out and have ability to roll back when the intuition doesn't match or they see anomalous behavior going on in the network, right? Just you may see anomalous in your network. You may not know how to act against that. And that's where it is important for them to build the automation around these decisions. When they are deploying AI, then they also need to think, okay, what is my next call to action and how is that automated and not automated? And that's going to be critical for their success. And trust is only going to come by when they are able to see that it was able to fix its mistakes. And that's important.
Yeah, and I'll just add that companies, when they start to think about how to deploy this, shouldn't be thinking, oh, I need to go hire AI experts and data scientists. What you really want to do is partner with the IBMs and the VMwares of the world that are providing that provisioning. And NVIDIA is providing a whole set of skills that we provide through companies like VMware in partnership and with IBM and many others. And so the point there is, don't think that you need to become an expert in AI, but rather use AI as a tool. That's really what we need to be doing.
Yep, good words. So, thanks very much for all that commentary. And I think we'll just trying to round up in conclusions. Kevin, I'll start with you there in terms of just final thoughts as we get ready to as we start to close out the session here.
Yeah, as I said, I think the AI is going to be much larger than people realize. The networking needs to build the foundation of that. We see in the virtual world becoming larger than the real world. And the virtual world is going to be a place where people develop new products, where they develop new applications, and they can test that. So even building a digital twin of your network and of your data center is going to be the way that people do things in the future. You wouldn't build a car without simulating it, or you wouldn't build a plane. And so we'll see the same thing now for data centers. People will actually build a digital twin using AI to detect things, anomalous behavior, anything, network hotspots. All of that type of activity will be modeled accurately and precisely. And so we think that AI is going to be much, much bigger, and the whole notion of a digital twin and what we call omniverse to model that very, very accurately.
Andrew?
Yep. Well, as you know, in this business, you get no points for effort, right? So when we engage, it's about outcomes. And the outcome really is, in this case, how do I reduce outage times in my infrastructure from, say, 2 hours to 2 minutes? Pick the things that are real outcomes. And those outcomes and getting to those outcomes extends from collecting the right data, having the right method of pushing out, and then having AI to be able to help you work through very, very quickly what those issues are and what the resolution piece is. And so if you don't enter an AI project or don't enter an automation project without a very distinct outcome that you want, then you're going to put a lot of effort in without coming to a conclusion. And let's just say that you don't get it from 2 hours to 2 minutes, but you get it from 2 hours to 10 minutes. That's a massive uplift and change. And you know what the destination was as you started the project. And that's how I'd encourage all of IBM's customers, all customers who have networks to pursue.
Gaurav?
Yeah, I would say that AI would be implicit, and we wouldn't be talking about like, oh, you need AI, but it would be all about like sophisticated decisions systems and network will have to do by itself, and that's where I see the future. So we would be talking a lot more about like what I call zero config, where customers shouldn't be needing to tune small set of things, but the systems and the solutions take care of those decisions automatically, and it will be built on AI's foundation.
Yeah, thanks. I'll offer you my final words here very quickly, is build your talent and team. And to Kevin's point a second ago here, this doesn't mean you're converting all of your programming staff and your operational staff to Lisp programmers. That's not what I mean. I think what you need to develop is to get a sense for what AI can do, what is provided by the vendors, get a real view in terms of the kind of functionality they're providing, and someone inside that can do the matching between what's available and what can be provided against your real requirements. And to Andrew's point there earlier too, is about, focusing in on those outcomes you're expecting. Is it focused in on problem resolution? Is it predictive analytics and modeling the digital twin and figuring out accelerating a digital rollout? That's what the kind of talent you're looking at, more analysis talent than, if you would, programming talent. Prioritize your targets. There's a lot of places that AI and networking applies. And you've got to probably prioritize your targets. Is it about smart analytics, kicking off some good automation capabilities? Is it about your network running itself more and more? Is it about easing deployments and configurations and things and protecting yourself against failures like we saw yesterday at the internet? So from that perspective, again, prioritize your targets. And as evidenced here, picking the right providers and the partners, and certainly a strong focus on, it's as much about services. These systems, once you put them in play, given your data, given the processing capabilities, these systems look different after you install them. So realize that the product that was developed and delivered to you and deployed is looking different over time and serving different needs for you. So services comes in very handy in terms of, again, the provider matching their capabilities and where they're going against where your system is now taking you. And beware the hype. We've mentioned it a few times here. And I'll leave you with that in terms of words of advice from IDC. I wanted to thank the panelists, Andrew, Kevin, Gaurav, provided great input to the audience. Sorry, we kept you a little bit longer than anticipated, but again, good conversation, good commentary, very worthwhile. And I'd like to certainly thank the audience for attending. And again, apologize for going a little bit long, but it's a very interesting topic. One, as Kevin, I think, alluded to earlier, it's going to be a lot bigger than people think, and it's probably coming a lot faster than people think in that regard. And don't expect too little from your AI-infused infrastructure providers.